Today we'll be working on lesson 2.2 transformations of absolute value functions, and this video is going to be for my GET kids, and I'm going to be working throughout the whole sheet. Probably I'm going to be doing number 1 and 3 and number 5 from the back. So let's start on number 1. When you are asked to graph an absolute value function using transformation, you can start by looking at the vertex of this absolute value function. And the vertex is usually h and k. So let's rewrite the general equation of an absolute value function. It's y equals a, absolute value of x minus h plus k. So the number usually on the inside of the absolute is h, and the number on the outside is going to be the k. So as you can see, k is negative 2 in this case, and h in this case is going to be negative 5. Because if you plug it in the absolute value x minus negative 5, the negative and the negative will become positive, and there you go. You got the x plus 5, the absolute value of x plus 5. So in this case, the h is negative 5, and the k is negative 2. Or you can just think about it as h being the opposite of the number on the inside, okay? Because a negative always change everything to the opposite. So let's try by graphing the vertex, which is in this case negative 5, negative 2. So that's the vertex. Now, after you find the vertex, your next step is to look at a. Is a positive or is it negative? As you can see, a is 3, so it's a positive number. So your function is going to be a v pointing upward, an opening upward function. So, and since a is 3, it means that your slope is 3. So you start counting from the vertex up 3 over 1. Up 3 over 1 until you get your v shape. And you do that on the other side, up 3 over 1 until you get your v shape on the other side. You connect them, and that's going to be your absolute value. So always remember, the first step is to decide what your vertex is. The next step is to decide what your a is it positive or negative, and then you look at the number to know how do you count upward. In this case, you count upward 3 over 1 because the slope is 3. Now let's talk about the transformation. So what transformation do you see compared to the parent function? Now the h, let's write that down. The h is negative 5, the k is negative 2, and the a is 3. So your function has a vertical shift down 2. Since k is negative, so it's a vertical shift down 2. Since the h is also negative, it's going to be a horizontal shift left 5. Now there's no reflection since a is positive, but a is 3. So what does that tell you? It's a vertical stretch by a factor of 3. So vertical stretch by a factor of 3. Or you can just say that your function got narrower by a factor of 3. So in order to decide that what we just did is right, you can draw the parent function, which is 0, 0, 1, 1, 2, 2, and so on, and negative 1, negative 1. Now you can see that your function has moved 1, 2, 3, 4, 5 to the left and down 2. And as you can see, it got narrower when you compare it to the parent function. Now I want you to pause the video and try to do number 2 on your own. Now I do hope you tried number 2 on your own, so please check with the answer key online. I'm going to go to number 3 now. So the same concept, to know what the vertex is, to graph this, you look at the h. h is going to be the number on the opposite of the inside, so that's a negative 1. And k is going to be the number on the outside, which is 2. And in this case, a is negative 1. Now guys, I don't want you to just memorize that h is going to be on the opposite of the inside. I want you to think about it. the x minus h. Okay, so what do you think h would be? So then you will have absolute value of x plus 1 like you have over here. So remember, for you to get plus 1, h has to be negative, because negative times negative will give you the plus 1. So in this case, h is negative 1. Okay, so let's graph the vertex, which is negative 1, 2. There you go. Now, the a is a negative number, so this is going to be an opening downward v shape. So when you count the slope, which is 1 in this case, you count down 1 over 1. See that? Down 1 over 1. What did I just do? Yeah. There you go. Now hopefully on your paper it's going to look much better. So that's going to be your V shape. So how is the transformation? As you can see, it moved left 1, up 2, and it got reflected. It didn't get narrower or wider because the a is 1, so it's the same size as the parent function. Okay, so the transformation as we mentioned. Now let's move on to the domain and range. Now the domain and range, as you can see, for every absolute value is negative infinity to infinity, since this is going to extend all the way to the left to negative infinity, and this is going to extend to the right to plus infinity. The range is going to be from bottom to top. As you can see, both of them are pointing downward, so that's a negative infinity all the way to the top, and it stops at 2. So then your range is going to be from negative infinity to 2 inclusive. Now I think I forgot to do the domain and range of the previous one, so let's do that. The domain is always negative infinity to infinity because it's going to extend from left to right, and your range is going to be from bottom to top. As you can see, it's from negative 2 all the way to plus infinity. There's nothing below negative 2. So negative 2 inclusive all the way to infinity. So that would be how you graph absolute value function and how you find the domain and range of those. Now let's move on to the back page. We'll be doing either 5 or 6. So let's do 6 together. Now, in number 6, they're asking you to write the equation. Okay? So to do that, you have to know what h, k, and a is. And you have to start with the general equation, which is in this case y equals a, absolute value of x minus h plus k. So I need to know what my h and k are. Now, as you can see, the vertex in this case is negative 2 for h and 3 for k. So the vertex is going to be negative 2, 3. So let's plug it in our general equation. So you put negative 2 for h plus 3. Now to know the slope, you start from the vertex and you try to count. So as you can see, it's going down 1 over 1, down 1 over 1. So the a is 1. And so this is going to be pointing downward. It opens downward, so the a is negative 1. So you rewrite the equation as y equals negative 1. You can just write negative x plus 2, absolute value of x plus 2 plus 3. So that's going to be your equation. Let's write it over here. Now, does this open upward or downward? You can say it opens down, because you can either say that a is negative, or you can just say, look at the figure, and you can see that the absolute value or the v shape is pointing downward. The domain is always negative infinity to infinity because it opens in both directions all the time. And as you can see, the range is going to be from bottom to top, so from negative infinity to the k of the vertex, so from negative infinity to 3, and my t is ready in time. So that's it for the practice. If you have any questions, please check the practice sheet.